Air quality in urban areas can reach hazardous levels in the winter when cold air traps air pollution close to the ground. In India's capital of New Delhi, during the month of November 2023, the average air quality index was over 350, with some neighborhoods exceeding 500. For perspective, the World Health Organization recommends that the average air quality index be less than 15 over 24 hours. Air pollution contributes to increased and more severe cases of lung and heart disease and other health conditions. These detrimental effects are exacerbated in vulnerable populations, including children, the elderly, and in people living or working in areas of high air pollution. The World Health Organization estimates that there were 4.2 million premature deaths in 2019 caused by air pollution. India is proposing to use geoengineering in a form of cloudseeding over New Delhi so that the raindrops trap particulate matter and remove pollution from the air. In this video, we will examine what is geoengineering, how is rain formed, how does cloud seeding work, and finally, why are some people against cloud seeding to reduce pollution? Stick around to the end of this video when we consider the geoengineering dilemma: should we use cloud seeding to reduce air pollution? Geoengineering is a process of intentionally manipulating the environment on a large scale. Examples include things like capturing carbon dioxide from the atmosphere and storing it underground, thinning clouds so they trap less heat, or placing material in the air to reflect sunlight before it enters the atmosphere. In the Indian proposal, they would inject salts into the atmosphere to cause water droplets to form rain. The hydrologic cycle is the circulation of water between the atmosphere and the earth. Surface water evaporates as water molecules are warmed and change from a liquid form of water into a gaseous water vapor. These warm water molecules rise in the atmosphere like a hot air balloon. Once these water molecules, or a hot air balloon, is higher in the atmosphere, it begins to cool down. To keep a hot air balloon floating, the operators have to continually heat the air. However, water molecules aren't heated in the atmosphere, so they will continue to cool down. As they cool, they begin to condense into small droplets of liquid water. Clouds are formed as more and more water condenses in the atmosphere. As these small water droplets fall, they form precipitation. When a warm front moves into an area of cold surface air, the warm, moist air is forced up into the atmosphere where it begins to cool. As it cools, water condenses, clouds form, and precipitation falls ahead of the front. On weather maps, a warm front is represented by a red line with semicircles representing the direction that the warm front is moving. When a cold front moves into an area of warm air, it slides under the warm air. The warm, moist air is again forced upward where it cools. Water condenses, clouds form, and precipitation falls as the warm air is pushed up and away. On weather maps, the cold front is represented by a blue line with triangles showing the direction the cold air is moving. As the warm, moist air rises in the atmosphere and cools, the colder air becomes saturated, and water droplets become too heavy to remain in the air. The drops begin to fall from the cold upper atmosphere. If the water drops fall through warm air on the way to the ground, rain is formed. If the drops remain cold all the way to the ground, they land as snow. Sleet and freezing rains are different because the water droplets pass through another layer of cold air before they hit the ground. As we can see, to get rain or other forms of precipitation, we need to force warm, moist air up into the atmosphere where it can cool. We can see this affecting the climate in mountainous areas. As warm air is pushed towards the windward side of a mountain, the air is forced upward, causing clouds to form and precipitation to fall. Often there is no moisture left in the air as it passes over the leeward side of the mountain, resulting in a rain shadow with decreased rainfall and drought-like conditions. We can apply this phenomenon to a real example by looking at the climate on either side of the Sierra Nevada mountain range in Southern California. The change in elevation from the Pacific coast along the windward side up to Mount Whitley closely mimics the diagram of the rain shadow effect, so we can expect to see similar results. We see much higher relative humidity and precipitation on the windward side of the Sierra Nevada mountain range and drought-like conditions on the leeward side. This contributes to dramatically different environments on either side of the mountain. There are lush forests on the windward side and drought-resistant plants on the leeward side. The first cloud seeding experiments were in the 1940s when researchers studied ways to prevent aircraft from icing over in mid-flight. The first cloud seeding occurred in 1946 when 6 pounds of dry ice were dropped into a cloud and snow began to fall almost immediately. In cloud seeding, substances such as silver iodide or other salts are released into clouds. The substances attract water and cause water vapor to condense into droplets faster than normal. The increased condensation could result in rainfall. However, there are limitations to this process because it works best when clouds are already formed, so it will not work in all situations. Currently, several states, China, and Middle Eastern countries are using cloud seeding to counter the effects of severe drought conditions. As early as 1947, scientists attempted to modify the severity of a hurricane with cloud seeding, but the effects were limited at best. With climate change contributing to increased storm severity, research into the use of cloud seeding to manage hurricanes continues. During the Vietnam War, the United States implemented Operation Popeye, which used cloud seeding in an attempt to extend the monsoon season and interfere with enemy supply lines by flooding roads and rivers. The success of this program was described as certainly limited and unverifiable. However, in response, in 1977, the United Nations established an international treaty called the Environmental Modification Convention that banned militaries or hostile forces from causing changes in weather patterns or triggering earthquakes, tsunamis, and other changes to climate patterns. A study published in 2021 examined air quality in 2 cities in China. They observed that air quality improved in 15 out of 18 rain or snow events. However, this effect was temporary, as after the precipitation had ended, air pollutions began to rise again. Still, they remained below the levels before the rain started. While cloud seeding use continues around the world, the science involved in the process remains uncertain, and it is difficult to predict potential harms. For instance, cloud seeding efforts have been linked to extreme flooding in the United Kingdom and the United Arab Emirates, as well as severe blizzard conditions in China. The increased rainfall, contaminated with pollutants in urban areas, is unable to infiltrate into the soil because of the impervious paved and built-up surfaces. This adds pollutants to the waterways that are often used as a source of drinking water. Similarly, the silver and other salts that are used to start the process are potentially hazardous if they accumulate in the environment. Cloud seeding doesn't create artificial rain. Rather, it causes the rain to form and fall in a different location, so it could potentially impact water supplies downwind. In the Middle East, where there are extensive efforts at cloud seeding to address severe droughts, there's already concern that these efforts limit rainfall in other areas. With this background, we're ready to consider our ethical dilemma in science for this week. Now, this dilemma is a geoengineering dilemma. Should we use cloud seeding to reduce air pollution? In order to answer that question, we must first consider, does the intention to clean the air justify interfering with the natural processes of weather and cloud formation? Does cloud seeding allow the root causes of air pollution, like automobile emissions and power plants, to continue unchecked? And finally, should the use of artificial rain to reduce air pollution be limited to avoid adding toxic materials to natural waterways such as ponds, lakes, rivers, and streams? Thank you for engaging in this important conversation about manipulating the weather to reduce the harmful effects of air pollution. In the description below is additional information, references, and a link to a lesson plan to accompany this video. Please comment with your thoughts on this topic or suggestions for future topics. If you enjoyed this video, please like it and subscribe for more conversations on the ethical impact of science and technology on society. Until next time, stay curious and be informed.